Let's do paper one. It was the junior exam for Gauteng 2024. I'll start with question one. We all know what question one is all about, right? And in question one, we need to solve for x. We are given those three equations. All of them are quadratic. That is because the highest exponent will be 2 for all of them. Let's start with the first one. You need to remember the rules. Now, when you look at the first one where we have 2x multiplied by 3x plus 4 equal to 0, you will have noticed that you have been given two factors. The first factor is 2x, and the second factor will be 3x plus 4. And when you multiply those two factors, they should give you a product of 0. In essence, there's no need to factorize, as this has already been factorized. We only have one term on the left-hand side, which is equal to 0. It's one term because brackets make a term 1 and it's multiplied with that 2x. Now, because that bracket, inside the bracket you have a binomial, it is multiplied by a monomial. These are the factors. We call them factors. The monomial will be 2x and the binomial will be 3x plus 4. The rules of multiplications are that any product of factors that you multiply and they give you 0, the only way you have a product of 0 is if one of the factors is equal to 0. Think about it. 2 times 0 is 0. 3 times 0 is 0. 10 times 0 is 0. A million times 0 is 0. What about 0 times 20? It is still 0. For you to have a product that is equal to 0, one of the factors must be 0. We don't know which factors it is in this case. Hence, we are going to take each of those factors and equate them to 0 because neither of them, actually one of them should be equal to 0. How do we do that? You will take 2x equated to 0, or the second factor, which is 3x, must to have a product of 0. Then you can solve for x. Since you have the linear equations, you know how to solve for x. For the first one, you will just divide both sides by 2. And for the second one, you transpose 4. That 4, you would have noticed that it was positive. To transpose means to move. So when you move it to the right-hand side, it will be negative. Notice that in the first equation, since we now have two equations, in the first equation, 2 divided by 2 will give you 1, and 0 divided by 2 will give you 0. In the second equation, we still need to solve for x, and that's what we are trying to do here. That's why we're isolating x. When you solve for x, you're just isolating x. In the second one, I will have to divide both sides by 3. I'll end up having x is equal to 0 or x is equals to negative 4 over 3. Let us move to the second one, which is 1.1. Here you are given the equation, and it must be equal to 0. You need to transpose 1 to the left-hand side. Now, as I said, the first step will be to equate this whole equation to zero. And for us to equate it to zero, we'll have to take the negative one, transpose it to the left-hand side so that we can be able to factorize. We say that we are writing it in standard form. The standard form is that it needs to be equal to zero. You basically mustn't have any number except for zero on the right-hand side. Once you have written it in standard form, you need to factorize. And if the equation does not allow you to factorize because this is quadratic, how do I know that it is quadratic? It is because the highest exponent or degree is 2. Now that tells me that I will have 2x solution. Once you have factorized, you need to equate each factor to 0, or otherwise make sure you substitute correctly into the quadratic formula, and then you solve. I can't tell if I can factorize or not until I have written the equation in standard form. Notice that negative 1 is actually negative. I highlighted the fact that it is negative. Transposing it, moving it to the left-hand side, will result in that negative changing to being positive. Now I have 0 right-hand side. That means I have written my quadratic equation in standard form. I need to factorize this. When I factorize, I always look at the first term and the last term. And I notice that it doesn't matter what I can do. There's no way those two terms multiplied and added will give me negative 4 as a middle term. I mean, 2 times 1 will give me 2, and 1 times 1 will give me 1. The highest I can get as a middle term will be negative 3. I can't get the negative 4. Therefore, I have no other choice but to use the quadratic equation. And this will be your quadratic equation. It is in the formula sheet. Before you can actually be able to substitute the values into the quadratic equation, you need to know what is what. For you to be able to write or substitute values into the correct variables, write the quadratic equation in standard form, and it should be like this. It should be ax squared plus bx plus c. And when you look at the equation that we have simplified, that 2 is a. Negative 4 is b. And that positive 1 is c. So I'm going to go into my quadratic equation where there is a. I will substitute 2. I will substitute 2 here. I will substitute 2 there. Negative 4 is b. In the quadratic equation where there is, I will substitute negative 4. And the last one is that positive 1. Where they see, I will substitute that positive 1. When you do your substitution, you did this in grade 8, please make sure you put it in brackets so that you don't mess up. You will notice that where there is B, I put the brackets and then I substituted by -4. And where there is A, I put the brackets and I substituted 2. Notice that this quadratic equation will give you 2x values because there's a plus minus. It means that one part of the equation is positive and the other one is negative. Hence, I wrote it separately like this. Now I can do my substitution. Come here. You start with negative, open brackets, -4, close brackets, plus square root, open brackets, -4, close brackets, raise it to the exponent of 2, -4, open brackets, 2, close brackets, open brackets, 1, close brackets, and then go to the denominator. You will have 2, open brackets, 2, close brackets. And then you equate. This is what you will get. To write that as a decimal, you will come here and change it into a decimal. So this 7 will change the 0 to 1. So it will be 1,71. That is the first solution. And then for me to get the second solution, I will just go back to where there was positive because that is the only thing that is different between these two equations. And I will just substitute negative there and press the equal sign and press change it to a decimal. That'll give you 0,29. And that's how you find your solutions. We good? Let's go to 1.1.3. As I have done with the previous ones, we always start with the steps. This, you shouldn't treat it indifferently. You treat it exactly the same way as you will treat a quadratic equation with an equal sign, just like any other equation. Step number 1, treat the inequality sign like an equal sign, meaning that the method doesn't change just because you have the inequality there. Note that for me to say the method will be the same, you will keep the inequality as it is, which is that greater or equal to, and you have to write this in standard form. And to write it in standard form, you need to transpose that +1. So you need to transpose +1 to the left-hand side, and then simplify that x minus 2 all squared. Once you have simplified that binomial, which is squared, add or subtract like terms. Remember, on the right-hand side, you'll be left with 0. After adding or subtracting like terms, then factorize. When you factorize, solve for x. The values of x that we find there, we call them critical values. Critical values or points, I wrote it as critical points here, is where x is equal to 0. The last step, which is step number 7, and this is worth 1 mark, by the way. You need to determine how x behaves around the critical point. I'll show you shortly. Let's get to it. As I've said, you'll notice that 1 is positive. When you transpose it to the left-hand side, it'll be negative. As I said, treat the inequality like is the equal sign. So when a number or a term moves from one side to the other, its sign changes. If it was positive, it'll change to be negative. Now, I can't add or subtract here. I need to simplify this. To simplify that, normally I follow this step. You take the first term and you square it. Obviously, that will give you x squared. And then you multiply all the terms. So you will multiply x with 2 and that 2. So x multiplied by negative 2 multiplied by 2, it'll give me, you multiply the integers. So negative 2 times 2 will give us 4, which will be negative, and then you just keep the variable, which is x. The last term will always be positive. So you will take this negative 2 here, all of it, square it, and it'll give you 4. So you just put these together to get this. You will notice that 4 and 1 are like terms, but 4 is positive, 1 is negative. Therefore, we'll subtract them and take the sign of the bigger number. 4 minus 1 will give us 3. The next step I said you must factorize. Because the last term is positive, both brackets will take the sign of the middle term, which is negative. And the factors, I will only consider the last term because the first term doesn't have a coefficient. I'll find the factors of 3. When I add them, they must give me the middle term, which is 4. But when I multiply them, they must give me 3. That's why I said factors. And that can only be 3 and 1. So in each bracket, the last term will be 3 and 1. Remember I said both brackets will take the sign of the middle term, which is negative. Now that I've got 2 factors multiplied, and they are greater or equal to 0, to find critical points, I'll have to equate each of those factors to 0. That's how it's like you're solving for x. It doesn't change. You will have 2 linear equations. The first one will be x minus 3 is equal to 0. The second one will be x minus 1 will be equal to 0. Then you solve. When you solve, remember you will just take this 3 to the right-hand side. You'll end up having x is equals to 3. Here you will take 1 to the right-hand side. You'll end up having x is equal to 1. Ultimately, you will end up having x is equals to 3 or x is equal to 1. Alternatively, to find those critical points, I don't like this method here because you want to be able to test when you need to. You can just square root both sides from the beginning. You take that equation over there and you just square root both sides. And when you square root both sides, the main aim is to get rid of the square on the left-hand side, that exponent of 2. That's why we're square rooting. If it was the exponent of 3, we are going to cube root. Note that the square root and the 2 will cross out, which is just 2 divided by 2. It is 1. On the right-hand side, the square root of 1 will be plus or minus 1. Hence, we will end up having x minus 2 is equal to 1, or x minus 2 equal to negative 3. And you transpose like we've done, you will take this 2 to the other side, it will become positive. You'll take this 2 to the other side, it's negative, it'll become positive. You'll end up having x is equals to 1 plus 2, or x is equals to negative 1 plus 2, which will ultimately give you x is equal to 3, or x is equal to 1. We call those critical values. These are the values where x will be equal to 0. You need to draw the timeline with those critical values, starting with those critical values.